All right, guys. So here is your review of integration techniques. Hopefully, it'll give you kind of a well-rounded, all-around examples of everything that we've discussed, minus the kind of the tricky inverse trig ones that we'll do after break. So our first one is a little bit of a softball. This has your three terms, so you can integrate them separately. Add one to the exponent and divide by your new exponent. So there's your first term. Same thing with the middle one. So you got x cubed, and you're going to divide by the new exponent 3. So that means you're going to have a negative 3 out front. And integration of 4 would be 4x. And don't forget that we have this constant c to worry about. So there's our answer. All right. The reason why that we were able to do that, those were all a simple power rule, x to some power, right? But the rest of these are going to be slightly different. So our sine of 3x here is a mini chain rule. So I know it's a tiny one, but we do have to use a u sub with chain rules, quotient rules, and product rules. So the innermost part of the function is a good thing to pick. Its derivative would just be 3 and dx. So we do have a dx. We don't have this extra 3, so I'm going to divide that over. So I can just substitute out dx and substitute in 1/3 I'm going to put out front since it's a coefficient, and dx here. What's left over then is sine. Instead of writing 3x, I'm going to put u. Sorry, I messed that up. It's not dx. What you're substituting in 1/3 du. So I got my 1/3, and there's your du. Now why that looked bad is you can't have x's and u's together. So this is our equation is all u's now, so we can go ahead and integrate. So how we do trig is whose derivative is positive sine x, and that would be negative cosine x, right? So it'd be cosine of u. So I'm gonna go ahead and substitute our 3x back in. Don't forget we had a 1/3 coefficient, and as always, you need a plus c. All right, so it's a little mini chain rule, but it ends up being a tad bit of work because we have to get that coefficient right out front. People that don't end up doing the chain rule or the u sub here will forget that coefficient, and that'll get them a lot of problems wrong. Now this one is a little bit more of a mess. It's obvious that we have a product rule, we have we have a product rule and a chain rule here. We're gonna have to do definitely a u sub, and again, a good technique is to use the innermost part of the function, but also its derivative is in the problem. 2x dx is exactly what we want, so that's perfect. So I'm going to swap that out and put du in. And our x squared plus 3 is our u, so we have u cubed, really. So what's nice about this is you can integrate this really easy. It's a power rule. So add 1 to the exponent, divide by your new exponent, and plus c. And just to finish that up, you need to plug your u back in. So x squared plus 3 all to the 4th over 4 plus c. And there you go. All right, and the last one here looks bad because it's a big division problem, and at first I would kind of I'd be a little scared of this one. What am I going to do? Until you just kind of go back to the basics. It is a quotient rule, so I should probably at least try a u substitution. Now you want to pick a u whose derivative is in the problem. That might help here. Or another guideline again is the denominator. If you got a quotient rule, just pick the denominator because your du can't be in the denominator. So I'm going to let 2w squared plus 3w minus 7 all be u. And the derivative of that would be 4w plus 3 dw. And that works out perfect. 4w plus 3 dw is exactly what I want. So all that comes out, and that's du. The denominator is u. Nothing left in the numerator, so I have to put a 1. And does that look familiar to you? And if you don't know, I don't have it memorized, I think this is a prime example to, there we go. This is a prime example to do one of these. Whose derivative is 1 over u du? And that'll hopefully lead you to ln of the absolute value of u plus c. Now you could write u there and then the second line write in what a u is, but I always leave a blank so I could just write 2w squared plus 3w minus 7, and you have answered the question. Okay, so here are a couple more examples that we can go over. I changed this problem a little bit because we needed something a little different that we're not getting to just yet to do it. But here is your classic division problem, quotient rule. So you could try rewriting. I would suggest a u sub here, and the denominator again is a really good pick. Now its derivative is 8x dx. Now we have a 2x dx. So the option I like to do is take that coefficient of 2 out and divide this 8 over. And that works out just fine because you'll have a 2 out front here. And when I go to take out x dx right here, oops, I forgot my x. That's x dx. So when I swap that out, I'm going to have a 1/8 and a du in here. And then what's left is that 4x squared plus 7 in the denominator, right? So do the integration, well, that's just ln of the absolute value of u, right? And out front you have 2 over 8, really. So that's going to end up being 1/4. Plug your u back in, and you have your plus c. And there's your answer. Now the absolute values with the ln are always necessary, but if you take a peek at this problem closer, x squared is always going to be positive. When you multiply by 4, it's always going to be positive. When you add 7, it's always going to be positive. So you'll see sometimes, like if you're trying to match a Schoology answer or a multiple choice answer, in this example, you won't need absolute value. All you need is parentheses. But I leave the absolute values there because it still works. It's still true. So just so you know, that could happen on the cases where it can only be positive. All right, so on to a square root problem. Okay, I don't think we've seen one of these yet, which is nice because this is the same exact piece of advice I would give you as if you were doing derivatives. Rewrite this. 3x plus 5 to the 1/2 power. This is a chain rule, so you're going to use a u sub, and you would pick the innermost part of the function. Its derivative is 3 dx. We don't have an extra 3, so we're going to divide the 3 over. You have this. So when you replace, a 1/3 du goes in for just dx. Well, that's supposed to be dx there, sorry. And you're going to have u to the 1/2 power. That's nice because now you just have a power rule. Add 1 to 1/2 and you get 3/2. Divide by your new exponent. When you divide by a fraction, it's easiest to multiply by the reciprocal. And you already had a 1/3 out front, plus c. So if we take care of those coefficients first, you'd have 2 over 9 u to the 3/2 plus c. So I'm going to go ahead and put my u in and finish my answer there. All right. And last but not least, an E problem. So first things first, 7 is just a coefficient, so I'm going to take that out. And I think that helps simplify the problem because you don't have to worry about that anymore. And you have when you have an E, you remember you want it to be e to the u. So 4x minus 1 is your u. The derivative is 4 dx. We don't have an extra 4 this time, so I'm going to divide the 4 over. And when you replace or substitute in, you already had a 7 out there. You're going to put the 1/4 out there and the du for your dx and your e to the u. Integration of e to the u du is e to the u plus c. And you're going to have, I believe, 7/4 as your coefficient, and your u is 4x minus 1. And that is that. Okay, so if you're ready, I have a couple more challenging problems. Now, these will be tough, or a little bit more challenging than these here, but these are really good, review problems. But here are a couple more, slightly more challenging. And right off the bat, you see a bunch of trig, and you could be a little scared by it. But The reason why this first one is tricky, it's got a product rule, chain rule. There's two chains. It could be kind of crazy. So, you want to pick something whose derivative is in the problem. Now, the thing that's nice. Sorry, I was just thinking maybe you could do it a second way, but you get a good way of thinking about it is pick something whose derivative is in the problem. So, a tangent of 4x. The reason why I like this, because I know that its derivative is secant squared, that's the derivative of the outside, leave the inside, times the derivative of the inside. Right? So, because this is a chain rule by itself. So, derivative of tan is secant squared, leave the inside 4x, times the derivative of the inside 4. Now, we have a secant squared of 4x dx. We don't want this 4, so that's the only thing that you need to get rid of. So you still have all of this that you can swap out. So all of that just becomes 1/4 du. And this is really just u. So you have integration of u du. That's it. So this problem became much simpler. Integrate, and you get u squared over 2. Add 1 to the exponent, which is 1, and divide by your new exponent. You already had a 4 there, and don't forget your plus c. So what that gives us is tangent of 4x squared over, I believe our coefficient is 1/8, plus c. And that was, a little bit more complicated one. Worked out kind of nice once you see it, though. So same thing here. Once you see it, it works out nice, but this one can be super complicated. But I told you a good rule of thumb is pick a u whose derivative is in the problem. A derivative is the denominator is usually a good one to pick. And here, just from experience with a lot of radicals, when you take the derivative of a square root, you always get, remember that's the same thing as to the 1/2 power, right? When you take the derivative of that, you always get another square root, but it'll end up being in the denominator. So I'm going to pick square root of 3x. I'm going to rewrite it, and its derivative is a chain rule, by the way. So derivative of the outside and leave the inside is what I've done, times the derivative of the inside there, right? We don't have this extra 3/2, so I'm going to multiply by the reciprocal over the other side. And what we have here is 3x to the negative 1/2 dx, right? Well, that is 1 over the square root of 3x dx, where 1 over the square root of 3x dx is all of that. And that ends up being just 2/3 du. So that's a huge substitution. So 2/3 du, and all of that orange in that equation goes away. This is our only thing that we're talking about is u, e to the u, because the du took out all the root 3x. So integration of e to the u du is e to the u plus c, and you had your 2/3. All you need to do now is plug your u in. So you get that answer. Looks a little complicated. Think through that a little bit. I think that'll help you out to kind of see it. It is a little tricky. Like I said, these are a little bit more complicated, but see if you can get work up to these problems. All right.